Good evening. Welcome to
Hi
the
everyone.
second event of the series. This event is going to be focused on the theme of industrial and academic synergy. And we know that North America, in specific Western USA, thrives with new neurotechnologies and new initiatives and new products. And especially also Toronto. And as a Toronto chapter of NeuroTechX, we are proud to have Joshua Brewster tonight as a guest of our event, of our webcast. Hi, John, how are you doing?
I'm doing all right, thanks, Chris. Yourself?
I'm doing well. I am excited about the meeting today with Josh. He seems to have some groundbreaking browser app for neural data acquisition and analysis. And we'll bring in Josh in a few minutes. But what do you think about these web apps that acquire, data from some device connected with a computer? So is this a new
Well,
paradigm?
I think so. I mean, firstly, just on Josh in general, he's a guy who just is I don't quite want to say a jack of all trades, but he does many excellent things in this space, and both in terms of hardware and software. And I think that's quite an interesting and kind of unique combination. So the hardware stuff, I'm not quite sure if he'll be talking so much about it, but we should definitely try to eke some comments out of him about Arduino and some of the FNIR stuff that he's been doing. But to your
Yeah.
question just now, I mean, this browser-based streaming app, like I saw a demo version of it about probably 5 months ago now. I'm
Hmm.
sure it's come along a lot since then, and even then it was like the best of its kind I'd seen before, just kind of really plug and play, which as people who know a little bit about trying to stream data from mobile devices like mobile EEG devices and so on, plug and play, like we love plug and play. We'd love it if it was so simple as plug and
Totally.
play.
Yeah.
Um,
Yeah, and we know how difficult it is to have devices work sometimes.
yeah,
End user have to struggle to find out the drivers, how to connect them. And
yeah,
it seems
custom
with this app,
installations, etc.
you know, yeah, totally. And it seems with this app is plug and play, and then not only do you have an interface to extract the raw data from the devices, what you have at the moment connected to the computer, but also you have the possibility to do analysis, right?
Right,
So I'm really
right.
excited by what Josh has to say tonight, and then we'll bring him in a few minutes. I wanted to mention that Alex Milenkovic from San Francisco chapter of NeuroTechX will be in the meeting today, will be online. And we are grateful to have this partnership with San Francisco, whereby we broadcast on Wednesdays and they broadcast on Thursday. And we have this tandem broadcast, not overlapping at least, right? Whereby they speak about, with great guests, about technologies and, devices as well in detail. And I think last time they had Ryan Field from Kernel and also Richard from OpenBCI, and of course the Alex Milenkovic from Korea. So I'm excited also to have him, conduct the San Francisco events on Thursdays. So please check them out as well. They are on the meetup site of NeuroTechX.
Yeah, and I think
Um,
a special mention as well to the SF Hack Nights, because this was, I don't think I mentioned this last time, but I know I'm a bit of a stuck record on this point, but I'll just go for it
yeah,
again. Is that the COVID hit, right? COVID hit, and then those of us who were really enjoying doing these live hack night sessions, like in physical places where we're getting people together and building code and stuff. That's that's that all stopped. So we needed an alternative, and
yeah,
that was the alternative that kind of sprung up, basically an online meeting group, and it was just buzzing, honestly, absolutely buzzing with like smart people, really passionate neurotechnology people
absolutely.
of various kinds, great speakers and guests, like you said, from BCI and Kernel and other things, and that just a real kind of intellectual fizz about it. So that was great, and in a
Love it.
way, I feel like what we're doing here is like one of the descendants of what got started last year with the SF Hack Night, events, and those are still going on though. So it's seeded many things.
Yeah, and then it's so exciting that we have this connection also with San Francisco, because I don't know if you heard about the news, the big news of coming from the West Coast of USA, about Neuralink being funded on a Series C for 205 millions.
Yeah.
Elon Musk's venture. And one of the venture capitalists inside the fund is Google Ventures, so which is very interesting. And also Paradromics from Austin, Texas. It was funded also for 22 millions in July. Neuralink was funded in August. So there are a lot of exciting news coming from the West Coast of USA, and we cherish this connection as well. But we're talking about high cost.
I know you know a lot about this particular development because you keep on top of those things and you read the Forbes articles and so on. So I mean, do you know? I have so many questions. Like, was that higher than expected? That amount, is it like surprisingly positive development, or were people expecting there to be a couple of million going into Neuralink sometime soon?
But exactly, it was not expected in this magnitude, right, John?
Right.
I think
right.
the sheer amount of corporate investors that united and then generated this Series C round is astounding. And just to mention that, also when in a field like neurotechnology, when you have big investments, this creates traction for the whole field. So when people like our companies like Neuralink and Paradromics get funded, in the West Coast and in USA, then this creates traction for the whole field everywhere in the world. So we see the ripple effect everywhere.
One of the things that I saw mentioned a few times in relation to this investment round and previous things as well, I guess, is that sometimes that they're kind of paired off against each other, right? Like Paradromics versus Neuralink, they're competitors, and some of the people who had put the investment in for this round, the round for Neuralink and the round for Paradromics, was the same people. Like I think Peter Thiel or someone or other who'd like put some money into both.
I'm not sure about that. I think we have Dolby Family Ventures for Paradromics, and we have Synergy Ventures and Westcott. But for Elon Musk's venture, it's quite a different makeup of the VC. You have, as I mentioned, Google Ventures, but also it's a different makeup. I can mention just a couple, but Valor Equity Partners, Vi Capital, Craft Ventures, they seem not to overlap, but of course, I don't know the details of subsidiaries of those venture VC capitalists.
And do we? I know that some of these people they're also kind of pushing digital health on various fronts. Like that's kind of the.
Correct.
I guess if you're kind of going to attach a label to this, right? I mean, of the labels you could attach to Neuralink, obviously one of them is like futurist vanity project type thing, right? Which attracts a certain amount. But
we hope not. We hope not.
Yeah, right. I mean, there's something to be said for rich people with vanity projects, great. But the place where the I guess interest seems to be coming from a commercial from an investment perspective seems to be just this kind of digital health economy, right? And
totally.
And having more data to put into your future digital health ecosystem.
I like this point about digital health because, and then we briefly segue into the tonight's presentation. As opposed to vanity projects, digital health has some specific requirements that high cost hardware cannot fulfill,
right.
Which is reach out to the end consumer, have a B2C model of the company. And that's why I think the presentation of tonight is particularly interesting because we can segue directly from high cost hardware from the West Coast into low cost hardware and availability to the general public and not vanity project. And I think it's important to mention that Josh put a lot of effort in that. So I'd like, actually, without further ado, to invite him on screen and then say hi to Josh.
While Josh is coming up, Cris, I think you should tell us what B2C is.
Business to consumer.
Business to consumer, not business to business. B2B
no.
and B2C. Is that
Totally.
those the two? Yeah. I know the lingo. I got the lingo.
Yeah, totally.
Yeah. I can schmooze in those circles now. B2B,
Cool.
B2C.
Hi, Josh.
Hey, Josh.
How you doing tonight?
Pretty good. How about you guys?
Good, good.
I'm still in LA traffic. I think we're gonna be here forever. This is Garrett.
LA traffic. Wow.
Yeah, we left a little late, but I can distract you guys with slides. So
yeah.
Well, you can talk to us about hardware as well, Josh. Well,
yep, I got all kinds of things to share. I'll share my master plan to take over the universe or whatever.
Oh wow, that's exactly what we wanted to hear.
Clear out of the way. There we go. Okay. This is. I might have to pause in the middle of this to go plug my laptop in when I get back. Okay, can you guys see?
Sure.
Okay. Nice.
Yeah, that's the infinite screen.
Nice effect.
I love that.
All
stuff.
right.
Did you see? There's a YouTube video about how you can take an image of a webcam and you can overlay it 3 times, and then if you just rotate it, you create fractals, like analog fractals.
I haven't seen the video, but
seen that one. No.
We just had an example.
It's like a code. There's a code parade on that. It's really good.
A fractal of your face, like infinite.
Well, any image. Face. Well, it's you have to point the webcam back at the camera or back at the screen. I mean, and then you could put like anything in the middle, and it'll create like fractals.
Right. I think I could do pretty well with like those like bumpy Mandelbrot, shapes because I have a good bumpy nose.
Well, there's like the ferns or whatever. It's really easy to make those.
So, Josh, tell us a little bit about yourself first. You are in Alaska, right?
Yeah. Well, no, actually, I just moved to Oregon in February. But yeah, I still say I'm from Alaska because that's where I've spent my life. Let me say. So I'm Josh Brewster. I'm now one of the heads of co-founders of Brainsatlay LLC. This is our new front. If you guys remember, Garrett Flynn presented a few months ago with Brainsatlay. It was just a little website with some it had like some cool stuff for working with like the Muse. And then I approached him. I was like, hey, we could make that. Like, for one, you're like the only other person I found that's kind of working on this in a raw way, so we should work together. And then plus I can make I can help, we can help each other legitimize this whole web platform idea. And so that was cool. So we partnered up, and I've lumped my hardware in with this whole thing because we're building a completely open source web and hardware like framework for working with biosensing. And we're able to make things that are just as high quality as anything on the market right now, like anything in the medical market. And we're able to also make it far, far cheaper. And our development cycle is like very lean, and like all our costs are so low that we can do this. And so we're able to, like, we're figuring out how to, make scalable technologies, and we're making like super modular stuff. I'll describe more of this. It's all very exciting.
It sounds like you're democratizing hardware.
So the history.
We're going to do the software too, because web is amazing. And we're taking advantage of all the most recent like developments in web. So we're able to make like a very robust application and like a distribution platform, a whole bunch of other things. It's all in like alpha, and some of these concepts are still, we're still like drafting this stuff, but it's all going to be there in the end. So yeah, okay. So I'm Josh. Garrett is my partner, and then our other partner is Jacob Tinkhauser. He's a scientist in New York, and he's just a really awesome guy. So then Brainsatlay, the software is, it's just a pure JavaScript, HTML, CSS application. We developed like the back end. We developed, like, instead of using React or anything, we developed all our own state management tools and stuff from scratch, just to get what we needed and to get like absolutely the best possible performance out of what we needed.
And Josh, may I interject every now and then, right? So you don't mind, right?
Go for it.
So for the audience, so these are all technologies connected in a web app, so in a browser, right?
Yeah, I'm going to show you guys after this. So I'll do a little demo so you can see how this actually works.
Cool.
And yeah, so it's just whatever. It's a website. You go to app.brainsatlay.com. I bet I didn't even put a link in this slideshow. And you can plug in any. You can plug in like a Muse. You can plug in the free EEG. There's the OpenBCI boards work. My HEGs work. And there's some others. So you can just plug it in and right through a browser, like on your desktop or phone, you can stream data. And then we have like signal analysis, and we've got multi-threading. We've got GPU, like FFTs and stuff all built in. It's all concepted, and it works really well. The like basic examples we have. And then we've built a framework with that to where we can very easily create, like in the browser, multi-threaded like compute applications, and we can write kernels on the GPU like in plain JavaScript.
And multi-threaded means that if you switch on the browser and then connect the device, the browser doesn't get stuck, right? So
yeah,
for the general audience.
You're taking, well, you can use multiple cores on your processor, and main core is running the UI, so you can offload a lot of the heavy duty stuff to the second one. And then with GPU JS, we can even offload the pre and post processing for the GPU math, really just to dump it back into an array on a thread. So then that gets passed back and there's no interruptions. And it's really cool. I benchmarked this stuff. This might be getting more into detail than I need to right now, but I was able to get so I can do 256 FFTs in real time in 10 to 20 milliseconds, and that's not FFT. Sorry, that was DFTs. So that's 512 times 512 times 14.
So for the general audience, FFT and DFT, it's some acronym that says discrete Fourier transform or fast Fourier transform, which are some ways of analyzing the data to provide spectral analysis of
it tells you
raw
the
signals.
frequencies. It tells you the frequencies and what the powers of those frequencies are. So then that's how you tell if somebody's having an alpha burst or something. So yeah, that's all there, and it's all.
That's in terms of the general framing as well. And I think the answer to this is pretty clear, is it not much? But what's the competitors here? What either gap are you filling that doesn't exist, and what, to the extent that there are other solutions, what are they? And this will all.
It'll take me a little while to paint a picture of this, but it's kind of a long story. So it started with me a few years ago, starting to work with the HEG, and I needed a really direct way to be able to code the software myself because it was just me doing this. So then
signal.
Well, yeah, for brain blood flow monitoring.
Oh.
It's just a little single sensor device.
On the chest?
No, it's this thing. It's my headband. So this is my HEG Juno V2. I just funded it on crowd supply.
That's come along.
Yeah, it's way better now.
It's a little bit more headbandy.
Oh wow! Show it on camera.
My mom
fabric-y than it
helped
did
me
before.
My mom makes these headbands because I'm too
Can you show the sensor?
doing a good job like this, man.
Josh, can you show the sensor?
Can I show the sensor? Oh
yeah.
This is an earlier version of it. The next version now has 3 LEDs, so there's 2 infrared LEDs. Wow. And they're ultra bright. I can see a crystal clear pulse waveform on my brain, and I've done enough tests to know that signal is most definitely my brain pulse more than my scalp pulse. I don't know. These are all things you start to wonder about. Anyway, so that it's a really neat little device. I was able to build it for what I sell them for $80. I can build them for $20, and it's $25-$30 at small scale. It's when it scales up, it gets freaking cheap, but I'm not that rich yet. Anyway, those things were being sold for $800 to $1,000. The one that's out right now is called Mendy, and they sell it for $300 or $400. I think they raised the price after the Kickstarter. But God, there's some chance I'm gonna keep this focused. So basically, I had this headset, and I needed a really nice way to develop the software. And then I realized, with this ESP32 chip, I can just I can literally code all the web software right into this thing, which it is. So you can like literally connect to this as if it's a Wi-Fi router and download the code to your browser and like use this device. So that was really neat, and it got me kind of thinking more about how I can make this all really lightweight and modular. And there's like no way to do that with commercial libraries in like a sane way. And then as I kept learning, I was like, oh, we could build like a whole like a computational framework on the web that's just as good as anything you could do in Python or MATLAB or whatever. Like the capabilities are just there now. And then it was also that much easier to actually code this stuff than it is in any of those languages. Plus, you get the full front end, which is like optimized, like all the front end tools with HTML. And so now we can build full, like runtime applications that run, real-time signal analysis. I mean, we can optimize it more, and then we have a whole framework that we can then build applications like with any kind of 2D, 3D content. We're building all kinds of analysis tools and stuff, and it's really easy to build plugins and algorithms. Like basically everything's modular in a way, so you can actually develop like end user experiences with all of this, and it's
Josh,
fairly consistently.
Yeah, so one detail that maybe skipped during your pitch is that this is all open source, right?
Yeah, it's all this software is GPL v3, and then the hardware is all MIT.
GPL means a license that is open source license.
Yeah, it's an open source license. All it means is if you use our code as like the base of your work, then you have to put the code out, like your code out open source as well. But you can still sell distributions. So this is kind of where we're going with this. Is we now Garrett for the past few months, he's been working on this thing called the Studio, and it's like a node editor in the browser, and you click on the nodes and you can edit just raw JavaScript, and like you hit run, it'll recompile for you. And then so basically you can go back and forth really easily, like working in just like Visual Studio code or whatever. You can write a plugin, and then the plugin shows up in the Studio for you, and then you go in and you can edit it there if you want to make even like you can basically make child plugins with tweaks or whatever.
Okay.
So you can start to build out whole libraries in a way, and then wait for it. You can Garrett's so satisfied about this part. You can press a button that says download project, and it'll actually wrap it up in a distributable form for you. This is still improving because we're going to make it so it also gives you the base files to do, so you can run a node command and create a desktop.
Oh, it's switching network on the car. Josh, you just went away for a second or two, but basically what is interesting about what you were saying is that you have a visual way of combining the components and then deploying them as a solution, right? Well, can you comment on that?
On the fly, you can simulate data or run data into these nodes, and you can then attach visuals to it. But then we're making it so then this can all be wrapped up into like a distributable desktop or mobile application. This all works on mobile, by the way. It's not like great yet because we haven't just gone the full length, but it runs, and it's all client side. We're not doing cloud bullshit. We have some things with Google Drive so you can like back up data, and we haven't fully taken advantage of that. But it's like you own everything. There's no stuff with privacy. We have a thing so it'll it can auto save your data for you, but it's it's easy to curate that. And then we're slowly transforming this into like an actual professional neurofeedback application built on all of this. So then we have all these modular tools. We have a free web-based neurofeedback software that's like on par with anything you would expect to see at clinic, I guess. Well, actually, what they use in clinics is like embarrassingly bad because it's all really old. It's like good. It's like reliable, but it's so old. I don't know.
Josh, can you tell a bit about the difference between the version on mobile and the version on a PC?
Well, right now it's just some stylization differences. The one thing you don't get on PC or on mobile is the USB serial, but we can do Bluetooth. So any like wireless devices we can connect through mobile. So like the Muse works, my HG works.
Doesn't that impact the data throughput?
You can stream through USB as well.
Yeah, through USB. Yeah, there's a USB serial. There's Chrome it's Web serial. Yeah, Web serial. There's a generic protocol now, so you can run serial ports into the web.
Right.
I mean, you have to know a little bit about how to like decode it, but it's really simple. I've got a dozen examples in our code here. So what we're going to do with this also is we're working on like a website and a community function, and we're going to work in a way so people can submit plugins and apps and everything like through the application or through our website, and we'll be able to start aggregating everybody into this sort of distribution platform. We can all start working together and developing these algorithms and things that are really like they just don't really exist yet in JavaScript. I've kind of laid the groundwork so we can actually build these things in a way that we don't lose our minds trying to code this stuff. and then we're trying to make it so that we can all start compiling all this through a community. And then, eventually, people will be able to, I mean, right now you can develop stuff so sophisticated that it's actually worth money. So we're going to try to integrate some of that as well into the platform so that, people could have potentially monetized content on this whole thing. But then following with that, right, my main thing has been building hardware. This software solution really came out of a necessity, but then also realizing we could synthesize a lot of really cool technologies and ideas that, I mean, thanks to the web today, I mean, really as of the past 2 years, like we're able to do what we're doing right now.
And this is why I was so bowled over by this platform, because I've been hearing from you all these like awesome, hardware things you've been putting together, and then you just pulled the like most advanced JavaScript brain analysis platform out the back in like.
Well, it wasn't out of the bag though.
Like,
I mean, this is a lot of iterating.
Like you just.
It sounds like I pulled it out of my ass, maybe, but it was definitely a lot of iterating.
Josh?
Yeah.
We have a question. So Kyle Matheson is asking if there is any timing delay on web serial.
No, not as far as I am aware. It's all, you set the baud rate and you set your whatever. Well, so the way I do it is like you have the baud rate. What I do is I just have a hard set delay. So I'll get a certain number of bytes coming in, and then I'll decode through as many end lines as I have, and then I'll wait like 10 milliseconds. That's so I can keep it like synced with frames, because there's no reason. But you can do it full real time where it's just raw data coming in, but then it really screws runtime up. So I have it optimized in a lot of my plugins. But so yeah, it's all
you tested it. You tested it with with LSL or you tested it with some other application?
With web serial? No, I mean I plugged the free AG32 in, and like it's running 32 channels and 512 samples per second. I was getting the raw data and I was getting it right on time, and it would come in chunks based off of actually the frame rate. It's like I think serial's tied to frame rate. So there's some interesting little quirks there, but it's really just to make it so that you don't overwhelm the actual UI in the end.
So you don't have clock drifts, you don't have jitters, delays. Did we lose Josh?
We lost Josh. Yeah, maybe it was a battery, maybe it was a web thing. So
well, what I understand,
while we're waiting for Josh to come back, you've done some hardware stuff before, right, Cris? A little bit.
Oh yeah, I was asking the question to Josh just because of that. I was asking the questions about, when you stream something to a mobile phone, you always have some delay of your raw data from, EEG or, the, LED device that you use to capture the blood flow. There is some intrinsic delay due to the connectivity, but also due to the electronics, right? So you have delays normally due to the time that it takes to go through the cable, which is some milliseconds. And you have delays due to clock drifts, which is temperature driven. So any hardware mounts a oscillatory quartz, and that generates a clock that is precise only to a certain amount of seconds, and then temperature influences that. So it's called clock drifts because you have some effects of delays increasing in time. And then you have the jitter, which is every time you send a package over to your receiver, to your mobile, phone, you have some delay that is sometime short, sometime long, and that creates a jitter around an average delay. So all these phenomena we observed when we implemented the headset in my previous work at Cognition, and then we were using both serial USB like you were pointing out, or Bluetooth 5, and then in both cases we see delays due to transmission due to the phenomena that I was pointing out. So yeah, I was curious to know that.
A lot better than Bluetooth 4?
Well, for once, definitely what is better, right? So there are some features of Bluetooth 5, which is an upgrade to Bluetooth 4.2, that are not there in the previous release, which introduced the possibility of making your data samples a bit longer and a bit shorter. So you can program the maximum transmission unit that you can send from the transmitter to the receiver, from the master to the peripheral. And for once, that's a flexibility that allows you to, use higher sampling rates, for example. So Josh was mentioning 500 hertz or samples per second in a transmission of his data. I guess with one sensor, it's more than enough. But then, some devices it's not enough. So you have Bluetooth 5 allows you, I think, I cannot disclose the details, but with the device that we were implementing at the time, it was a Cognition. It was remarkable the amount of data that can be sent over Bluetooth 5.
But the delays, so you can improve on the delays. I mean, the numbers I'm familiar with, I've never actually quantified this. It's actually very hard to properly benchmark. I know Jason Kowaleski did do this with Blue Muse, but the numbers that I kind of have in my head for, say, Muse Bluetooth delays are on the order of tens of milliseconds, like 10, 20, 30. Does that sound like the right ballpark number?
If you're lucky, yeah, sure.
If you're lucky, okay.
Sometimes in other devices, I cannot make names, but in other devices I have experienced about 100 milliseconds. Depends on the connection.
Right. So I mean that's a big difference, right? I feel like with a lot of EEG applications, it's not ideal. But if you're talking about an ERP, look, like if it's systematically-ish delayed by 10 to 20 milliseconds or even 20 to 40 milliseconds, I can cope with that given as long as I know. But 100 milliseconds, that's a different kettle of fish, because then you kind of your main components typically in ERPs are separated by about 50 to 100 milliseconds. So you're just going to kind of push your P100 into the area of your N200 or something like that. And
if you're recording EEG,
what's going on?
Yeah, totally. If you're recording EEG, it's not really ideal. But as Josh pointed out, is for example recording blood flow. And what's the sampling frequency of blood flow, right? So you don't need a high sampling frequency, and delays can be also longer, especially when you deal with frequencies that are not around 10 to 40 hertz. The frequency of typical brain waves for clinical studies from EEG. And then for, like you mentioned, EEG for evoked-related potentials, or ERP, like you say, I guess you need the full spectrum, from 1 hertz to 40, 50 hertz to be able to run standardized studies with the standardized montages of the EEG. So if you have 100 milliseconds, what is it? 100 milliseconds falls, the equivalent time, 100 milliseconds is the frequency of 10 seconds, like you were saying. And alpha is a very important frequency in EEG technology. So if you're already delayed by that much, it's critical. So what Josh was mentioning, that he was able to transmit with little or no delay with his web app, it's remarkable. So I know that's for sure a problem for many hardware components. So I'm looking forward to
we had a good
Josh
question.
back.
Well, we had a question. Kyle was asking about if there were timing delays on web serial, but I think the thing that I was thinking is, well, a lot of this technology or this software, it's oriented towards low cost and like low channel count devices, but it would be really great if you could also plug in a BiosMe or an EGI if you happen to have one of those to hand, right? Which sometimes is the case for benchmarking, if nothing else, and like not have to do things differently. And those are all USB controlled. Right?
BiosMe, let's say for the general audience, BiosMe and EGI are high number of channels and high sampling rate EEG devices that are clinically validated, FDA also certified.
Like high-end research grade EEG systems.
Exactly. So I bet delays and jitters and clock drifts are dealt with there. Also, many other features are dealt with, like signal-to-noise ratio. So do you also have the impression that low-cost hardware has a bit of a pitfall, which is, it comes with a sort of, lower quality of the recordings?
Well, I mean, I don't think very many people would disagree with that, but I don't think it's there's two components to it, aren't there? With the EEG specifically, one is that, I mean, I'm not necessarily the person to comment on whether the components deliver better signal relative for certain kind of newer systems versus your like classic silver chloride EEG electrode. But there's, in addition to the components, there's the setup expectations, right? Specifically dry, right? Yeah. So usually with low grade, with low channel count consumer grade systems, they're also expected to be dry and expected to be like on the head straight away. Whereas with research systems, like we take a bit of time to put the gel in. It takes like half an hour, right? Because the objective is high quality signal, but that's not what you're going to want to be doing in a naturalistic consumer context. So I would say that's probably even in the greater challenge, really, isn't it? In terms of the signal quality is like going to dry and going to expectation of just works like that.
Hi, Josh. Welcome back. You're all set, right? So that was exciting.
That was fun. I didn't die in time.
Good job, that's the excitement of a live cast, right? So we have things happening all the time.
It's a roller coaster.
And Josh,
just press the hide button, Josh.
Hide button.
We're all set. We see it on screen.
Menu.
Oh, okay.
No, the presentation is where you left it. We were quickly wrapping up what you were saying about, clock drifts and, jitter and latencies. And Gerald points out in the comments that he has seen 400 milliseconds jitter and 8 seconds time drifts in 30K samples per second clinical EEGs. So there is something to comment. I have 2 points for you, Josh, I would like you to comment on. One is low-cost hardware less reliable in terms of data acquisition and latencies? And 2, why are clinical devices so crappy? Can we say that sometimes?
Yeah. You just baited me. No, there's no difference in quality. Actually, guys, by the way, the industry defines innovation not just as better like specs, they also call it better cost innovation. So what you find at Texas Instruments or AD or all these whoever's, I mean, look, okay, I'll just show you, all right? This is my latest prototype. This is going to be our Apex thing of we're gonna do a lot with this little chip. So what this is a little $5 ADD converter. It's 8 channels, 24 bits. If you want to look it up, it's called the ADS 131M08. There you go. And I'm putting out open source all kinds of stuff for this. So it's a 32 KSPS sigma delta ADC. It at the higher.
Can you translate in English?
I know, right? So at the higher gain, it has enough impedance to do EEG as well. So you can put the gain up to 128 times, and the signal is beautiful. I get less than 300 nanovolts of noise. It's rated at
24 bits?
Yeah. It's basically almost as good as the free EG32, and that's without any like extra stuff. Like the free EG32 needs like a special voltage reference, and it has some more isolation things on it. This is plugged into an ESP32 here. This thing's not known for being like good for signal analysis. I'm getting 300 nanovolts of freaking noise on this thing. It's unbelievable. The free EG32 is 250 nanovolts. So look, it's a really high-powered ADC. It has the things it needs to do, like the noise canceling with the electrodes attached to your head, and it's really fast. And again, high gain, so you can really multiply the signal to see the spikes in their full glory. And it's a really cool thing. And then I think if you buy 1,000 of them, they're like $3.50 or something. Like, it's absurd. And so there you go. Like what I remember, Peter Van Dusen, brain trainer guy, he told me that he started in the late 90s, it was in the late 90s, selling like single channel EEGs, and they were like 12-bit with all this analog stuff to basically multiply the signal and do like capture and hold circuits, all this special stuff. And that was like a $15,000 piece of equipment. That's just like in the late 90s. It's 21. I'm telling you, here's a $3.50 thing that does, like basically,
much better.
I want it to do, really, in terms of signal quality, for this type of what
about battery consumption? Like, is this ADS 131 like that you mentioned? Does it draw a lot of current? What's the battery life?
I don't know the exact number. I could look up the spec sheet now, but it's really low power. So then we've developed a microcontroller. I'm waiting on the prototype. Hopefully 2 weeks. I keep saying 2 weeks. It's been 2 weeks. It's not. It's 2 more weeks. I'm just waiting on the reply from PCBWay. But
so where are they coming from? Like this chip. Like what's the industry that's driving the the innovation there? Like is there like,
are these low cost?
Is it biosensors or is it something completely different?
No, I think it has to do with industrial sensing, like running industry, like industrial lines and stuff. Like these are, analog to digital converters are essentially like really generic components, and they usually, like the ESP32 has an ADC in it, and all kinds of things usually have some of these in them. So they're very generic. And then as far as I understand, like factories and stuff that will use tons of sensors all over the place. And they'll have guys that like develop whole microcontroller like management systems. And I think that's probably what's driving that. Maybe cars, like smart cars and stuff now, they're also
but there is no requirement like biosensing that has such high quality requirements for acquisition of data, because automotive doesn't have the same frequencies. Or what do you measure in automotive that needs that sensitivity?
I don't know. I honestly don't know. Like this ADC was designed for
analog digital
load. You were doing like load measurements on power lines, so they're trying to get like really fine grained power, irregularities on a line. So that's what that was spec'd out for. Obviously, like EEG is just low power, so it works. And it turns out the impedance on that is just enough that you get really pretty good EEG signal.
Understood.
EEG signals are actually pretty simple. Like it's all low frequency, so it's not sluggish. And so you need a pretty minimal sampling rate, and you need good noise control, and then everything you do digitally.
I understood, but is that why we need sometimes 16,000 samples per second sampling for EEG2? Sure. Because of control of the noise? If the frequency of the brain is so sluggish, why do we need to sample up to 16Ks or 32Ks?
Well, this one is, even if I'm putting it out at 200 or 500 samples per second, it is still sampling at 32,000. Well, I think that just comes down to the electrical engineering. Like ADCs are essentially, they give you a list of numbers, and then that list of numbers corresponds to the voltage based off of the reference. So there's like a 1.2 volt voltage reference, and then all that's happening is like, it's like a signal's coming in, and it's just like, it's like the hammer game at the circus where you hit it and it tells you how strong you are. It's like that. It's just like pushing these bits up, and then that's your output. So it's not like, I mean, you can see how that
dynamic range,
precise. Yeah, that's like the dynamic range, and and the resolution. But you're essentially like, it's a mechanical movement. It's like it's a mechanical switch that's happening at some point. It's some bit that's flipping or something, and then that has a certain amount of noise associated with it. So then they create these really high level. I mean, so there's all kinds of ways to try to overcome that. Like, try to get as close to the thing you're sampling as possible, because then you're removing all the deviations in your copper. Like, try to sample as much as you can, because then all those deviations, you just average that out, right? The randomness will cancel itself out. That's actually the best reason to just oversample. It's because you can just use the randomness.
But Josh, when you oversample, also there is an inverse relationship with the figure of noise inside your chip, right? So is that correct? So if the higher you sample, the lower the quality, the signal to noise ratio. Right?
Exactly. Sometimes. Well, sigma delta, I mean, they're really just sampling at the rate that they sample at. Actually, they sample something. Well, the rate they're spec'd at, they're usually sampling like 2 million times per second, like some actually super high number, and then they only output so much. You're just averaging, right? You're just averaging, because what happens, you just average down to the window that you need, because you know that, like, if you average 32,500 samples, well, your Nyquist frequency is still 250, so that's and then the resolution's really good. Okay, so that's all that, and then going back to the presentation now. Where was I? So I'm developing low-cost hardware with all this. So I've managed to crowdfund all three of these. The free EG32, that's by Dmitry in Russia, and then there's headsets on the bottom there. Those are by Bernard. So those are the free EG32s that they're wearing. And then he's actually in Germany right now doing exactly that, but with all these professional, if you can call them that, professional meditators, people who like do this.
Yeah, you can call that.
They'll spend 8 hours a day, doing these things. And so he's able to show these people, like, some of these people can consistently produce like alpha burst activity and just for hours. And
at will?
Yeah, at will. It's just closed eye meditation. And some of them are like do it open eye. In fact, some people teach the open eye format. It's very interesting. So they even were able to use one of my, I had, before Brainsatlay, I had this, it's called I was just calling it Web BCI, but it was just like a demo. And they were able to use that, like just that demo with the free EG32. This was at another one of these Purusha places, but it was in India with Bernard's EEG. And they were able to show basically one group chanting slowly versus one group chanting fast. And the group chanting slower was actually like producing more of the alpha burst activity.
Why don't you pick up artifacts?
Well, it picks up artifacts too. Bernard's actually done a lot of work on it. He's added optical ports to like the data lines so that now there's no noise that comes through USB. Basically, it's like noise free at this point.
Which product?
This is the
EEG?
free EG32, with Bernard's headsets. Wow. I wish I could show you the optical. I have the board. Here, but I don't have the ports hooked up to it yet. It's really cool though. That eliminates noise
from the picture there. Are they quite comfortable?
They are. They don't feel like they grip my head at all. He's actually doing even more. I mean, every week he's got more like improvements on this thing, and he's doing everything he can to make this as comfortable as possible so you can just wear it forever. And right now you can, but he keeps improving it. He's an artist, man. And he's going to make like a 32 channel version of this. He's thinking about 64. He's going to add a standard DB25 connector set to his headsets as well, so people can use their other generic
you can stack them together, right? The free EG.
Yeah. Well, so Dmitry designed them so that you can literally hook these pins together on the boards. I don't know if he's actually tested it yet, but basically they'll share a clock so you can know that they're synchronous. And then you can then have stacked channels that way.
And do you know if they have some way to get rid of the line noise?
The line noise on the cables?
Yeah.
The main thing is actually just to get I mean, this is a basic thing in electrical engineering, is you want to get the ADC to be as close to the actual signal as possible, the signal source. So what these headsets have these flexible PCBs, and then on the back of the flexible PCB is actually the free EG32. So it's actually hanging off the back of their head. So it's really like a very direct connection. There's no 10-foot cable or whatever. Now we don't have this board doesn't have what you'll normally see on like a dedicated EEG is they'll have like RC filters and stuff built right into the lines.
Yeah.
So it'll filter out. It'll do bandpass filtering and stuff in analog. This is not that. This is literally just like a raw ADC. So we do everything else in post using IRR filters basically, and that does it. That scrubs it. I coded some filters from scratch and they work great. Well, I didn't code them from scratch. I took a Python example that worked amazingly, and
some library, but maybe we'll get to that later, right?
Yeah. So that's what I funded, right? That's what I've got working right now, and then we're working on more stuff. So this is the diffuse optical tomography prototype.
Wow.
This is
fancy.
So this is assembled. Kyle Matthewson's helping me with this. So these are so my HEG, right? It's the lights and the sensors. Now here's the lights and the sensors, but now I've arrayed whatever, many of them. And then what you do is you flash each light independently, and each of these sensors will pick up some amount of that. And then what you do is you estimate the shapes of those light paths coming from each source and sync, and then you can build a 3D image out of that. And it turns out it's accurate to fMRI.
Wow.
Like over 90%, 92%. I forget. Kyle can tell you. It's totally like spot on, basically. And it gives you a shallow fMRI, but that's enough to see neocortical activity. And that's
what
really
frequency?
Well, it's light. So what you're seeing is metabolic activation. It's all light. So it's red and infrared light. Whatever, 900. Well, for infrared, it's like 800 to like 1200
nanometers.
Yeah, and red's it's like 700 and below.
But what frequency of the brain signals can you get? The bold signal?
Well, there's the bold signal, and then you can see pulse, you can see blood pressure changes, and then also, I've been talking to one of my, I'm in LA, and so Bob Marsh is here, one of the guys who made one of the original HEGs, and he said they actually found. What they found was that when they were trading beta-theta ratio for ADHD, that the bold response or whatever actually seemed to correlate with it.
Okay.
And so then they were able to basically replace the beta-theta ratio with the HEG, like just the bold ratio, and that was fine. And then it was actually way more effective for doing like ADHD training, because it was just like what you're doing instead is you're watching this nice slow wave of your brain blood flow, and when you breathe in, you see very clear rises. I'll show you this.
Understood.
It's all very clear, so then you also get very clear feedback just from like your emotional mental state as well with this thing, which is also, it's very interesting. And what happens is when you start to map this stuff in 3D, you'll find that there's whole activation patterns just in your metabolic activity, and they're very dynamic and very much based off of like what you're doing at any given time. And the other part is it's completely repeatable. What?
Josh, so this is very interesting. I wanted to step back 1 second and make a point. So this is a spatial map or tomography of brain activity inside the brain, right? Equivalent to functional MRI. In the last episode of this season 1, Kyle Matheson was presenting the different typologies of functional near-infrared spectroscopy, which is what you're applying here. And he was talking about time-dependent or steady-state stimulation of the light source, right? What kind of time, light source stimulation do you employ here?
Like actually using the infrared to stimulate the brain? Is that what you're saying?
I think it means the continuous wave. Yeah, Cal says continuous wave.
I see. I really haven't touched the photobiomodulation stuff because I just don't understand it enough. That's really my answer. I'm trying to do the mapping, and I'm trying to explore the behavioral side of it. that's already a really big challenge. I'll think about the PVM stuff next. I'm really excited for this.
So 16.
I can flash these fast enough that I can essentially get a real-time image of my brain metabolism, and I'm really excited for that because now it's going to be a real-time volumetric image of my brain activity.
Every 1 second.
With that density, so you've got 16 optical channels.
I can flash. I can get the full brightness out of these in like 60 to 100 microseconds. So I can flash these in microseconds to build maps really freaking fast. These sensors respond in like nanoseconds. So I can flash these basically as fast as my controller will allow it, and we should be good to go to get.
So in one sense, what you're saying, Josh, is that you can do time-dependent modulations at will with this kind of design.
I suppose I could, yeah.
That's interesting.
Again, I really haven't explored the whole. If you go read my HEG white paper, I did look at like astrocyte studies and looking at metabolic processes in the brain, and what they would do is they would dope these astrocytes with like calcium or something, or some compound with calcium in it, and then they would flash the infrared light at it, and then it would be like dope, so it would actually stimulate the response of that astrocyte. It would stimulate the metabolic activity. Also, they're tied around your capillaries, so they cause vasodilation. So when you're breathing in, one of the things you're actually doing, like when you're doing deep breathing exercise, you actually end up stimulating like all of that. And it's very fascinating.
Does it work also with your hair?
Yeah. These are light pipes. This is all Kyle's suggestion. So these can do pretty well to get through your hair, and it's not uncomfortable at all.
So it is. I thought it was like a headband type like thing you have in the design there, but is it actually going to be a helmet or a cap?
Well, this one is an experiment. The 16-channel one will be a nice headband.
Okay.
Right? This one, I'm going to see if I can do the tomography and see if I can get any good data, and then there. The 16-channel one, that'll be an actual like legit full forehead FNIRS, and the design is called high density. It's a high density, so there's like really short channel separations there between the short channels, and then what you do is you're overlaying distances based off of those 3D estimations you do.
So in my understanding, you can really do a lot of customization with FNIRS, functional near-infrared spectroscopy.
Yeah. And what you see in like the commercial applications, they'll give you like a helmet, and you can kind of move the probes around so you can probe different areas. I'm going to start with like a headband, and this thing's specifically designed for monitoring your visual cortex. So that's going to be, I don't know, let me get that working first. We'll see what I do.
Once you get to,
have you actually looked into the tomographic reconstruction part then?
I'm working on that right now. I'm waiting on Kyle to.
Is that challenging?
Dumbass with this math. Well, it's just learning how to do 3D modeling. Really, like I'm doing the solution Kyle gave me. It's essentially voxels and like hit detection, and like it's really basic like graphical type like stuff you're doing, like stuff you do in 3D graphics. It's just a very clever implementation of it using actually real data.
Yeah, and Josh, once you figure out the technology, then you will have to look into the industrial design and comfort. And on this account, I have a question, maybe premature, but I have a question from Alex Rice-Cowrie from the audience. And he's asking, can you give an example of one of the design decisions your artist or yourself made to have a cap comfortable enough to wear all day long, like the material, the pressures you put in on?
Bernard, yeah. Bernard, he worked on that thing he's been working on it for 3 years now. He looked at all the designs that were out there and realized he wasn't going to do any of that. He started from scratch with what he does professional 3D printing with the materials like polypropylene. It's really beautiful. It's all engineering material. And then he mixes that with there's some like surgical tubing to connect them. And then he just kept working that design out until he got it to be as absolutely comfortable as possible.
Yeah, I'd say it's a little bit like
It's
there's the open BCI kind of like hard 3D printed, ultra cortex.
Yeah, and
it's kind of like a kind of Lego scaffold thing.
Right.
It's a bit like that, but it's flexible. And it's also a little bit like
it's totally
the electrical
flexible.
geodesics net, which is also a net with channels.
Yeah,
but,
definitely.
Not
sure, there was some
kind
inspiration.
not kind of a drawstring type as well.
Right. Yeah, and it does have those. It's so good, guys.
So it's silicon, right? Silicon based.
Silicon what?
The strings that you see in the meditators is silicon based. So, but not, by the way, he's in the Netherlands, right?
Mm-hmm. Yeah.
Yeah, he's
currently in Germany doing this. And then what's going to happen is they're doing this group EEG stuff at this TM. It's called Parisha. They're one of the sort of world-class TM groups, and they help popularize it basically for the West. And they're doing group EEG tests right now. Now that he's gotten rid of all the noise problems that they're having, like with the optical cables and stuff, they're looking for any kind of group effect. And then if they can find it, they're going to send them like to all their groups around the world to try to correlate these things. And then, once they're really sure about that, then they're going to use that to then improve their training methods, because now they have like some markers of not just meditating with alpha bursts, but like group meditating. And it's all very, it's a lot of hypotheticals right now. It's really cool. And they're going to be, they've got software.
Wow.
They're using some of the stuff. Like I'm trying to tailor some of the stuff we're making with Brainsatlay to like really help them. I don't know. It's just very exciting. So I didn't even finish talking about all the hardware we're making. This board down here is Jacob's. It's an ECG breakout board. So we're testing that. It's a generic ECG chip you'll find in like Fitbits and other things. And it's a really great chip. It lets you do like wrist ECG, so you don't need to wear the leads all over your body. It has like a shitload of whatever gain on it. And then the board over here, this is our prototype. This is just like a breakout test board. I'm testing like whatever battery and USB and other things. And then there's a super low power Cortex M4 and BLE 5.2 board for a microcontroller. The thing uses less than, it's like 5 to 6 milliamps of battery power running full speed with the BLE. And BLE 5.2, guys, it can stream up to 2 megabits per second. Yeah. And for context, the free EG32 running at 512 samples per second, 32 channels, 24 bits, so that's 3 bits per channel. That was like 50 KB per second. Yeah. So we have a shitload of room now to like stream a lot of data over wireless, and it's all super low power. And then on the backside, what's that?
Sorry, you were talking about the backside, which is probably battery consumption.
Well, the backside is going to be, well, no. Actually, 5 to 10 milliamps, okay, is like nothing. A typical battery in like a phone will have 2,000 minimum milliamps, and then we can get little battery packs that have, 500, 1,000 milliamps, and basically we can make this thing last for freaking days. And we're gonna have.
I want to hear those. I want to hear those numbers again, actually, because I'm just kind of like bowled over, right? So you said a 32 channel EEG at 512.
Yep. In 24 bits, and that's like 50. This is like 50 to 60.
That's like 50 kilobytes. So whereas you can get like 2 megabytes. Did he say with the BLE? Yep. So that's like a 20th of the load that you can push.
Yeah, and that's streaming like a couple
32 channel EEG.
Yeah, I'm not shitting. These are the numbers right now. I need to test this to prove this. Put my money where my mouth is.
Yeah, but sure. But
it's really damn good.
These really fancy, the 4, 6, 8 channel mobile EEG systems that we're all like super excited about, and I'm sure there's lots of constraints on the device construction. But I know, like, in terms of channel count, like they don't go over 16 for a reason.
Yeah, well, the BLE 5, this is new as of this year, as far as I understand. Right. Yeah, we're just on the edge of that. Thank God. Jacob was the one who pointed this stuff out to us.
Wow.
Because I was really hesitant on whether we would try to make our own microcontroller yet, but then it's like, okay, it's time. Like, it's time.
Yeah, that sounds like
So Josh,
and then on the backside of that is an 8-channel. It's that 8-channel ADC. So then it's a microcontroller. We'll have the breakout pins on it, and then it'll have so those will be like expansion pins. And then the plan is we'll have, like additional breakout boards of these chips, and you'll be able to daisy chain them all onto one board, so that you can just have your mobile EEG. We're going to try to collapse this down as small as possible.
and Josh, I have a question from the audience. Is this project on screen now? Is this the heartbeat measure device?
Well, the ECG is what'll measure your heartbeat. Yeah, that's this board here on the middle.
And what are the other components?
What do you mean specifically? Like on
there
this?
is a slew of components on screen. One on the right is the
This is the microcontroller
chip.
That we're working on. This is a 16-channel FNIRS DOT sensor. This is a 28-channel FNIRS 28-channel FNIRS DOT sensor. This is an LED relay. This is what we're going to use to drive all the LEDs on these giant things.
And it's all on the same device.
28. Just on channels, like the kernel system is 50-ish, right? Have I got that right? Maybe Carl.
It's only 50 channels? Well, wait, no. I think it's what they have one channel in the middle, and then they have a ring of like 8 lights. Yeah. That's smart.
50 units, modular units.
Sure.
Potentially. I'm just curious, like, what you approach, or what you can approach in terms of the number of units.
I haven't thought about again, I'm still just trying to make the one version work, but it should be no problem to keep expanding this thing. Now that board is with the microcontroller, it's just like a Cortex M4. So we might start to hit a limit in terms of like throughput. But it all remains to be tested. And then we're looking into even more advanced microcontroller stuff. So we'll see. I don't know if I'm going to do a time flow right away. That's a lot.
Richard Waldman from OpenBCI is asking a question from the audience.
Sure.
And he's asking what company is this project coming from? And I think I can answer that is Brainsatlay, right?
Yeah, Brainsatlay LLC.
Brainsatlay.
This is all open source though, or at least like these. If it's not, I mean, those DOT boards are published. The microcontroller board, I'm gonna test it before I publish it, just so I know it works. I don't wanna...
So Richard wants the link.
And this is all me, really. Like, look. Okay, this is where I'm getting with this. By the way, next slide. By the way, so I have values. Okay, look, I was like a NASA nerd. Like, I grew up, thinking like I want to have like a future that's really cool, and then now I'm growing up in a world that it's like not that great in a lot of ways, and I'm thinking about how I want to model the things that I really value in the community and in the world, and like the things that inspire me. And I really want to build a business that reflects like sort of I got to intern at NASA, and I got to work with to learn from the upper, like the directors of the facilities there. And they were some of the most optimistic, just like beautiful people I've ever met. And like, this is at NASA, right? Like, they don't give a shit about money. Like, really, they were just complaining that they couldn't get enough money to do the work they wanted to do, and that they were constantly getting their shit shut down by the government, due to quarterly cycles and budgets. And I mean, my mentor, he was one of the guys, he was the chief engineer on the freaking Atlas V rocket that was going to get us to Mars, and that got shut down. And there's a bunch of other ones. The Dream Chaser project I was on, that was another project that was shut down because the government, what is in the 90s or early 2000s, they kind of pivoted away from letting NASA do all the work to giving NASA money to let private companies do the work for them. And it really just became like a money funnel. And then NASA ends up like just going out to try to court, well, not NASA specifically, but some of the former employees would go out to just like court rich guys who would want to invest in these scientific projects that really probably aren't going to make any money. But that's the only way they can actually like legally fund these projects. So that was like the Dream Chaser. It was like one of the former astronauts that was going to be like flying that thing back in the late 80s, found a guy, and then now it's like the winning project or whatever of their whole competition. It's just ridiculous because it's like we knew this stuff we knew how to do these things. The professional community that was dedicated to like the mission came up with this stuff so long ago. And then it got screwed because we took all the money away from the people that actually deserved it. And now it's like, I've worked with, I'm still working on like grant stuff, and there's some groups that are working with us on that. And I'll tell you more about why I'm in LA right now, which is for this whole other project, which is awesome. And what I'm seeing though is that I can just put my foot down and say, no, we're going to make low cost, accessible technologies. We're going to keep our process so lean that our costs never go up to a point where we need to, scam somebody out of money for these things. And then I can find whatever public sources I can find to help fund this stuff. And in general, I can decide, we're going to have clean margins in a way that we can scale and make sure that the people who really need this technology are actually going to get it, and that we're actually going to develop this stuff to the quality that it needs to be to like treatmental illnesses or we're working with implant people as well. And I mean, there's a whole, textbook full of problems there. But it's all a really interesting space. And what I see is we need a community solution, and we need a way to engage the community and get us all to be creating stuff. I mean, I'm just some guy, I'm from Alaska. I decided to do this because I thought it was really meaningful. And I had been educated in a lot of, radical sort of politics, I don't know. Whatever. I don't know. I just think we really need to find a way to like unify this and get rid of this stupid corporate, competition. And we need to make our business models efficient so that we're not throwing money away and forcing to like charge higher prices for things. Yeah.
I appreciate the mission. However, and I'm going to ask a little bit of a strange question here.
Sure.
So if you release a software under a GPL license, you're not really helping the market develop, because it's not an MIT or BSD license where you can also see other people thrive with it. You are imposing a open source model that not everybody might be able to adopt.
Well, there's we had a long conversation about this. We kept going back and forth on MIT GPL, and there's some strategy there where we think that reasonably all these technologies should be open sourced and should be published under public, like in a way that can meet public scrutiny. And then we should be pooling our technologies together so that, we can still sell distributions, right? It's like if I put that thing on the App Store, I could charge, whatever I wanted for it. Or whatever versions of apps we make. Like there's ways to develop the content out in ways that are publishable. And then there's ways to bring people in with their work where they don't necessarily have to mix up what they want with their licensing. It's just like, if they're going to contribute to the core thing, we want that to be a public open discourse and something that like anybody can contribute to, mainly so we can show this to like, high schoolers and students and people who need to learn how to do these things really well so they can, do it even better.
Yeah, it's quite a refreshing, it's a refreshing perspective. I'm so kind of with you on so much of this, but I think, specifically to the point that Cris is raising, I think open source scientific software development communities, they exist, but they don't. Right. They kind of exist on the back of government funds and some philanthropy funds, right? Like that. And obviously, like enthusiasts just kind of building stuff like that. They aren't really. Things like NumFocus, right? Like NumPy, right? Like some of these things that are actually like making half the world work. They have teams of about 5 developers, because of the way that core functionality is not kind of prioritized so much relative to commercializable, licensable units. Right, and so you end up with like a lot of this core, software infrastructure, which is obviously high quality and like does important things, but it kind of the room for pooling of strengths and people extending the breadth and the depth of the center is kind of tailed off. by the
See, it's such a
incentive.
I don't know. There's so many assumptions with a lot of this, though, right? Like, again, what I saw, like with NASA and all this sort of like, very high level engineering that they're doing, it's all pioneering stuff. And I could argue that a lot of this is similar in its sort of like scope and breadth and what it actually takes to sort of understand this technology. I mean, it's actually really simple, though, on a mechanical level and on a materials level. The industry's kind of taking care of all the money, like the manufacturing problems that make this stuff expensive in the first place. All this stuff's becoming so damn standardized that there's no reason for us to like not make it as affordable and as accessible as possible. And then, okay, this is actually all sort of a good segue. We're thinking about like, how can we make like a viable model that we can all contribute to? And what I think is like, if we actually had a functioning government and a functioning like civil society, and like if the SBA was a little more efficient, we could actually just be funding our work that we want to do and that we know is meaningful and that we know is like actually stretching like, all this insane technical education we all get, right? I mean, this is what I saw at NASA is like they were dedicated to the mission. They saw that, the real outcome of all this was, 10 years, 20 years in the future, having these amazing possibilities in front of us, and who knows what else, right? I mean, looking at today, I don't think we could have imagined 20 years ago that we would have like all this shit that like isn't like in front of me right now. I mean, it's like amazing. And it's like we could sort of see it because of how this, we see this sort of scaling of our economies and our technologies, but it's like now it's here, but it's underutilized. Now that it's here, it's especially underutilized. We're trying to think of like, so like we're operating Brainsatlay as a cooperative between Garrett and me and Jacob. And so what we're doing is we just have we have democratic ways to organize the work we're doing to where we know we're creating projects that are marketable, and we're able to control our costs. And it's just so damn low anyway, from prototyping and like, I don't know, all the signal analysis. I mean, come on, it's like EE 101 stuff, really. it's also overblown, man. It's so upsetting. We spend so much time on marketing and hyping that we forget like it's actually really simple stuff. Basically, we can democratically decide, okay, we're putting in this labor. Hey, let's. Like right now, we're just giving equal shares to each other for the work we're doing because that's just nice. But we can start to negotiate a very mature system where we can all come in as creators to, work on projects in ways where we can all start to generate income for ourselves and with each other, and, start to build a collaborative scheme. Because what happens eventually is we make this work, and I have made this work just like by myself, and hopefully when we get to this next wave of hardware, we'll make it work for the three of us. Is just like we just are mature about it. Like, and we know that once we are making money and we're making sales and we're established in the market and people like our stuff, if we're good enough to make stuff that's likable, right? Then like we're gonna get to a point where we're in surplus, right? And then there's gonna be a point where we're all creating so much, and it's gonna be so easy for us to like collaborate and expand into all the little niches that we could hit with our highly generalized technologies. Like I don't think money is going to be an object after a point if we just grit our teeth and collaborate, and we're doing it cooperatively. Like Jacobs has some of his own projects that it's like, hey, we've got this whole framework here, now please take advantage of it, please make your own he's a very passionate guy with this tech, so it's like he wants a way, he needs an outlet, it's like, well, here it is, and it's open source, there's no weird ethics or weird business strategies involved, set the margins, control the costs yourself, like do the things you want to do, and so that we can make not just the market, but eventually the sort of collaborative ecosystem that can support us. Because I mean, really, if the government was functioning, like I was saying, it would basically just be funding this stuff, because the government's just the people. Idealistically, it's just the people deciding collectively what to do with their money and how to build infrastructure that's going to better serve our future collectively, right? But we can essentially mimic that, not as a government organization, but without, capitulating to the business language of, the ultimate goal of a corporation is to maximize profit to its shareholders. It's like, who gives a shit? It's like, what I give a shit about is that we're creating things that are new and are reaching people and making a difference. And like, I mean,
okay, so here's the question on this.
Sure.
So with, I guess you would say that of the part of the picture that is well covered at this point by you, is the development side. Right, the core technology, the core hardware, core software, etc. So, as to you have stages, but I think on the previous slide as well, what are the the parts of this picture that are like you would need the most new input in? What do you think needs the most kind of creative development?
Right. Well, that's a very broad. Well, like we're doing right now what we think needs the most, and that's like actually making an open hardware base where we're like using the cheapest, the best stuff right now. So it's not like anybody can do better than that. And then we're also software side, same thing. We're taking advantage of web technologies that now are good enough to do fully, like smooth interactive experiences that also have like really capable like backends for doing all the analysis, or we actually have multiplayer, so you can do remote streaming. I mean, there's networking, there's just so many damn possibilities, and we've made it just like really easy. I mean, we need to document this stuff. But for us, it's really easy to just create all this stuff like in 5-10 minutes. So we can make a multiplayer app that does some DSP on your EEG and can compare it to like somebody else's results, and just like boom, there you go. It works. It's done. It's no longer this whole effort, and I need to hire a whole team to do this, and it's going to cost me $1 million, and now I need to charge $1.5 million, or I need to make $1.5 million in returns, and I got my quarterlies, all this shit. It's like,
right. But like one type of thing you might need is people you're partnering with, scientists maybe who are
the algorithms.
I was going to say validating, but even just kind of testing, right? You're going to want like ultimately like a pipeline of user tester guinea pigs,
exactly,
right? and have that whole process figured out. And that's something in the kind of in the kind of clinical and human like research area is actually there's all kinds of problems with it, but it's in some ways like a well-oiled machine in terms of like getting research subjects in to do studies. Like people have somewhat figured out how to do that effectively, and it's not hard to do, but it takes.
Dude, look, man, I've gotten so many offers from scientists who are all working on their PhDs, or they're just research people who need something to do, or they're just interested in what I'm doing. And they reach out often. They just offer to do the lab testing for free because it's good for them for whatever they're doing, and then it's awesome for me. And then they know because I'm working in an open context, and I constantly express the fact that like I believe in this for bigger reasons other than me buying a fucking house or something, like they're into it, man. So part of this is we're designing this, and then we're trying to legitimize. Yeah, go for it.
Sorry to interrupt you. The framework is amazing, and I understand the open hardware attempt has been tried before, and it failed before. So I think one of the reasons it failed before is, technologists sometimes fail to find a pathway to distribution and go-to-market strategy, and also monetization. So how do you go to the market with this platform and do actually make it sustainable, a sustainable circular economy?
Right. Well, so what we're doing is, like I said, we're trying to. I mean, we've got a really good tech demo right now with Brainsatlay. We're going to then turn that into something that actually looks like a professional workflow for like neurofeedback. We're going to have our devices that we're going to be marketing for neurofeedback. So there you go. That takes care of us, ideally. And we've got all the resources we need and the people we need at this point to make like a product. And then what we do is we, hit that hard. We're constantly, planning to the next step of, okay, here's all this other hardware we could be working on. We're doing like a lot of community work. So like we're going to be teaching a high school class this fall. Jacob's teaching a high school class as well over in New York. We're working with buckle
How
up.
do you go to the market? For example, we have examples of open hardware, companies like OpenBCI that successfully, were implemented this new paradigm. And that was one example of strategy on how to go to market. So would you copy that business model? Would you develop a different one to go to the market? How do you monetize, sustainably?
Well, so there's enough interest in the sort of maker and research community that, like, for small scale, we're fine, and then we can continue to, like, man, as much as it's cool to like run a big marketing campaign and make it work, like, we still, like, the best part of this is like the word of mouth and the community building part. Like, that's hard work. Like, that's what we're focused on right now, at least making the platform capable of handling that, and then we'll worry about actually like marketing that. But we can sell the hardware, no problem. We're working with groups. So there's this project called Buckle Up that we're working with, and this is cool because we're taking that 8-channel and BLE board that I showed you, and we're actually going to make a version of that that's going to be a wrist wearable. And we're working with this rehab center here in LA that they want us to apply that technology to see if we can, model people who are going through the rehab process. Basically starting to get actual, like, 24/7 live biometric data using all these different peripherals and those, nice 8 channels.
So you're targeting, for example, models that involve social VC or makers or communities, for example, to help out with social issues such as mental health, but also homelessness, right? You were talking about a project with homeless people.
Yeah, well, this is relevant to that. I might have mentioned a while ago, a friend of mine, I'm helping him with one of his EEG projects, and he, like, one of his colleagues, he's like an old timer psychologist who does biofeedback, and he said one of his colleagues would go around doing that for homeless people. That might have been what I told you. We're working right now with the addiction. Like, this is a rehab population, so these are pretty, like, well-to-do people, but they have really serious, like, mental health problems. And then so there's that project. Garrett with Dong Song's lab at USC. They put in a $150,000 Facebook grant. So we're also going to use that 8-channel board to create a 8-channel EMG. There's a lot of money right there for that. There's this group. Well, this is not necessarily for money, but BCI for Kids is that's a group up in Calgary, and they work with people with kids with cerebral palsy, and they're just trying to use brain-computer interfaces and, like, whatever kind of off-the-shelf hardware they can use to try to give these kids some stuff they can interact with. I've got this collaboration still ongoing with the Biofeedback Institute of LA. They're the ones who made the HGs. Like, I was just in my friend's backyard helping her set up a dome, and then we're going to use a projector, and then we're going to use the Sensorium and Brainsatlay with my HGs, and we're going to put a whole group in there, and all of us use that to, like, I don't know, make visuals. There's one actual SBIR grant that a research group at USC is writing basically for us. I mean, with us. They're just research guys. They do grants and research for a living. So they were working with us in a way to where they'll basically, if they get that funding, it'll fund hardware development, and it'll fund legitimizing, like, the technology against like clinical studies, SBIR stuff that you have to do. And NeuroTechX, you guys, I mean, I consider, I really am looking to you guys, hopefully, as we get Brainsatlay, fully functional for the community side and fully documented, et cetera. Like, I mean, I think you guys are really going to enjoy it. But, and there's all these people that are approaching us that want to help us implement algorithms just for the hell of it, and, like, these are scientists, not just like really anybody could, but these are scientists who also know what they're doing to some degree. Like, because it's just such a positive community model, people really just want to jump in with us and start working with us and start figuring out how, we can all make this sustainable together, right? I mean, because there's easily a way. We're kind of working in a sort of ragtag way just to get all this hardware together and to make Brainsatlay look at like something that's professional, right? But we've been making sure we cover all our bases first, just with the core technology and what we understand we can get for quality.
Is there a definition, right? Would you say like so you're talking about like building the ecosystem and the community and all this. So I guess you mean like broadly speaking, the community around the devices that you're and the software that you're building, but I think you mean like somewhat more broadly than that as well. So I guess maybe you mean like
we want to get more people
community around
with us
around the kind of the genre of like low cost open source hardware designs and software. Like, is that what's like I guess the definition of the outer extent of what Brainsatlay should be to you? Like, is it stop at your stuff, or does it, how far beyond that does it go?
No. I mean, look, I get contacted by people sometimes who like, they see my HG project and they might be in another country and they're like, oh, I want to make that. So it's like, okay, well, let me tell you exactly how to make that. Let me help you as much as possible. And I'm not asking for money. I'm not asking for partnership. I don't give a fuck, because what I want to see is this technology get out there. I want to see it make a difference, and I want to see it get validated. I want to see the science expand, because I want to see what the damn future is. Like, and it's about empowering everybody, because what it ends up happening is it all comes back in a good way. I mean, you're building a community. People appreciate that. And there's realistic ways within all this to make money and to make sure that you're making your margins, not just to survive, but to grow. But you're not growing like to me, to say, oh yeah, I'm going to move a mountain, but I'm also going to make sure that I guarantee you a 200% return on your investment. To me, that's parasitic. To me, it's like, no, the people investing should be the ones like making things, and then like reinvesting. I don't know, like it should be like an infrastructure that we're building and treating it like this is like part of our sort of like medical and civic discourse and our education in a way. Because these are all these technologies that are just out there. They're generic, but they're so powerful and they're very underutilized, and we haven't necessarily crafted it into this fashion that like lets us fully engage with it, I guess.
Josh, that sounds like the makeup of a no-profit, right?
Yeah, sort of.
We have an interested listener that would like to have the slides. Is that possible for him to reach out?
Yeah.
Okay.
And then, there you go. This is our last slide. We're thinking about later, as we mature, we also want to do like supply chain modeling and basically start to sort of make sure that everything's actually ethical and that we're not just relying on like, Chinese slave labor and other things. There's so much we can do with this, because it's like we can just learn how to do this and kind of more or less, help build our society. I mean, I don't know. It's fun stuff. I really love thinking about like public policies and like ways we could actually, empower the right people who just want to do the work and see people flourish at the end of the day. I just hate business, man. I want us to have a good time.
You're in business, man. You are in business yourself.
Oh, I know, but it's a temporary thing. Let's put it that way.
So let's open it up for a bigger discussion now. So I have a lot of questions. This was an amazing presentation, Josh. Thanks so much for being here tonight.
Amazing
Thank
slides,
you for letting
Josh. So much stuff, so many cool projects, and such a kind of a big vision as well. I didn't actually realize, I wasn't expecting the social commentary in the middle. That was
I can't help myself.
Positive surprise.
On this account, in fact, we do have already a first question coming from the audience from Ilya Steen that says, what are the social implications of the technology?
Let's see if the social implications. Well, we can just talk about neurofeedback, right, and biotechnology, and
why not?
Like, well, I mean, it's so what I saw, and what got me into this was like specifically this HEG. It's a blood flow monitor, right? So I'm just taking one sensor and I'm looking relatively at that change in my blood oxygen saturation, basically in my brain, and then that's correlated with my mental activity just as much as my just like physical health. and it's actually very strongly correlated with stress, turns out. And what it kind of revealed to me is like, oh, my whole metabolic system in my brain is actually highly reactive to stress, and then I can just sort of breathe. And it turns out, as you get deeper in this physiology, there's actually all kinds of things that we can do to more or less control that process and correct ourselves in a way. And then what I started finding as I was getting out in the community and talking to people about how my friends who are struggling with these things, I mean, none of them had any conception of like what stress was, what it like meant to like have a brain that's a physical organ with rules that you can't just abuse and pour as much alcohol and pills into as you want or whatever. Like there's these things that are very basic sort of conceptions, yet they're almost completely lost in our education, right? And then I'm seeing so many people that I really love like suffer because it's like they don't know how to get better. It's not like there's enough services out there, or at least they don't know how to grab onto the ones that might be good enough. I mean, really, most of them just aren't good enough. And then, and then there's this whole side of it about, it's really about this own person getting more involved and getting more empowered so that they can take better care of themselves and be a higher functioning person in this community. And what was so amazing was just like actually getting that sort of fundamental basic psych education about how these sort of ordinary things affect our health in the long term, and how it's actually really toxic, and actually how most, like I would say, developmental like affective disorders, depression to schizophrenia, certain classes of those diseases are all basically like a person just getting way too stressed out for way too long. And so there's a really large body of these mental illnesses that where if you can help that person treat the stress, you might not cure the mental illness, but you're going to leave that person in a way, way better state than you found them. And that's not invasive, right?
You find this is a way to disengage the physical condition from the perception of the physical condition. That's what neurofeedback would inform about, right? So most of the time, the physical condition, or talking about mental health, right? In this particular example that you mentioned, the physical condition would only deteriorate if you don't have a feedback on your own behavior on top of that, right?
Yeah, essentially, like it's like totally random what'll happen to you unless you're actually like engaged in that process in some way. Really what happens is we learn really negative coping mechanisms. We learn to more or less destroy ourselves instead of build ourselves up. And then when you're so low, you don't even know how to get out of there. And it's all like when you're actually in therapy with people, right? It's just this very progressive process of helping them build themselves back up again. But so much, I know there's a lot that's going to change, I think, in the sort of psychiatric world in terms of like how we sort of stage treatments, like not going straight to pills, but like actually giving that person like not necessarily this device, but like that education so that they can understand all these processes in their body that are then driving these behaviors and these thoughts that they might be having, because that lets you get outside of it and start to, finding another way into actually like helping, get truth testing.
So this is powerful, Josh. This is really powerful, and I understand the mission and understand why you guys at Brainsatlay want to do that, and like yourself, also other realities like in open hardware. But one of the, playing devil's advocate for a second, allow me that. One of the biggest criticisms of this is that, you also need investors, you also need to get the machine running, and to do so most of the times, and correct me if I'm wrong, but what I've learned in the field is that you need to validate your technology by having a little trial, having an abstract or having a publication or something that demonstrates that everything that you want to do is really working like you claim, right? So how do you go about that? Do you have an infrastructure to have outcomes both in the scientific and the patent community, and what's that? What's the strategy?
No patents. Well, maybe buckle up. Some of this, we're doing some like psychiatric communications stuff for them, which might be IP. I mean, I don't really care, but that's like a VC thing, so there'll probably have to be some IP there. So our costs are so minimal, man. We don't need investors. Like, it costs me a couple $100 to go make like 5 of these new boards.
But you need validation.
Well, so then the validations is coming through like, look, there's people helping us write SBIR grants. There's people reaching out from all over the world saying, hey, get this lab, help us let us help you. And then like this this rehab group, they approached us and they're like, look, we need something different because what
Understood.
Doesn't work.
So you're piggybacking on subsidies, teaming up with subsidies.
Yeah, all these people that are interest groups, essentially, that we want to serve with this technology in a real way, well, they're right there waiting for us. Like, we can make all this stuff so low cost, and there's enough funding from different places. We can scrap together things as we need.
Is there though? Because you can say you're successful in particular. You and your group are successful with piggybacking on subsidies because people reach out to you. But if anybody else would like to build a community like yourself, they maybe would have to choose a different investing stream, right? And a different technology. Would you say that the subsidy way of going towards that validation of data is the only way? Because you need IRB, you need ethic committees to allow you to use your devices.
Well,
and
like
so
I'm
on.
not an academic or a doctor, right? Like I don't have any way to get IRBs. Like, we go through people that are like, that's what they do best. Like what we do really well is we can build the hardware and the software, and we can sort of make the vision clear, but we're not the guys that are going to go out and fill every single freaking thing that we could do with this, because at this point it's like, or at least it's going to get to a point where it's going to be like virtually infinite what we can actually start to build out with those things.
Right. Of course, credibility comes from validated data.
Viable, yeah. Well,
viability is different from validation, right? Viability is different from validating the data as really having a mental impact.
For the rehab group, well, so Richard Waltman said Google Amber had attempted this exactly. What they attempted was to find a biomarker for depression using EEG. And the way they did it, they couldn't find anything. And that's not what we're doing. We're not looking for necessarily biomarkers of mental illness. No, we're seeing people who are suffering, and we're saying to you, here's how your body works. Here's how you can start to do things to take control of your life in a way, but also like you're literally building your physiology. It's freaking exercise. There's a lot of actual mental psychotherapy with this as well. Actually, we're going multimodal as well. We're going to make a mixed EEG and FNIRS, so 4 FNIRS, 4 EEG for the forehead. That's what we're doing next for Brainsatlay. So that'll be our flagship. We're looking to see how we can just empower the therapy process, which is that's an interpersonal thing. We're not trying to automate that away necessarily, but we're trying to give whatever communication and data tools we can get to put some objective markers on this and just try to make it more efficient. Like the other side for the rehab program isn't just this wearable that we're coming up with. It's this whole chat system and organizing system so that clients in their a client can go get all the providers they have to get them all into the same more or less chat and content aggregation space with each other. And it's like a like a HIPAA compliant system or whatever.
Okay. But you're teaming up.
Yeah. I don't know. We're trying to just explore ways to actually use this stuff to actually improve the objectivity of the process, not just say, oh, we're gonna automate away psychiatry or psychology. No, you can't. Sorry, that's care work. You're never gonna get rid of people.
Your answer is educating me on the real mission of Brainsatlay, which is, as a different ecosystem, you coexist with partners that are able to validate the data for you, but you care about the technology and distribution, right? The viability, like you say. So that's a very interesting point.
In the same way as all technology companies do, right? Same thing with Muse. Oh, yeah. Right. They have a device. They build the device around an application. They do it in a standard commercial context, but all of their science has been done with external partners.
Sure.
Right? So it's same thing.
Yeah, that's clear.
Yeah.
Yeah. No, that's just because that's so beyond our capacity. We can do what we can do, and then that has a natural fit with a lot of that everyone else.
I guess the question I would have is when, so in terms of the funding model, the small grants and collaborators with small grants and stuff probably you're right. Especially if you do a good job of networking, that's options there. The question is, how much do you need, right? Yeah. So it's
this has changed. This has changed so much in the past few years. For software, you need a good computer to program. That's it. The web is there. Right. It's all there. And really, it's about you need to choose the tools that are most efficient. Like,
so I mean,
a solution will take you forever. Web will take you over. Like, you can do it overnight, basically.
So let's say I'm saying, like, I'm thinking kind of, you know, could you say that the I don't want to say what's the right word, the revenue, the money you need to go along per year, and I don't need quotes on, you know, salaries and stuff, but like under $1 million or under $500,000 US, right? Like, the reason I'm saying this is because there's a certain kind of like bracket. This is kind of to Chris's point, really. I think is like there's a certain bracket where you can more or less rely on kind of acquiring small scale amounts with from various sources, as long as you're partnering and kind of getting enough people, putting enough hours into trying to pull that in. But get past, say, a couple of $1 million, right? And then there's a lot less in those kind of numbers. So I feel like the magnitudes that you kind of need for your, you know, year-to-year operations would depend like the extent to which you can rely on that.
Yeah. I mean, it's not like we need a lot of money. I mean,
yeah,
we're not trying to become billionaires here. We're trying to make it so it's sustainable for us to do this thing that forms a really sort of core function for the community, so that the community can all make sustainable ways to do their work. That's not necessarily them being, you know, slaves to corporate and signing away all their IP to some contract or to academia where you don't have IP. You spend 6 months broke writing a grant, and then you spend 6 months flush with cash, and then you're doing the work, and then it kind of goes.
And then you have to pay to read your own paper.
Yeah. Yeah, there's a way. Like, it's like a lot. I don't know. There could be so much less friction in that process, and like like I feel like for this type of stuff, it should be more or less not necessarily academics, but people who have that ethical training, like actually starting and running these businesses and basically being fed from the academic community with the most relevant information. But that's all been like a public discourse.
So what is the actual kind of team size that you kind of would need for this operation on like a 5-year timescale? You can kind of, you know, do something completely differently, but do you think it needs to be like a 40-person team at some point, or a 5-person team, or a 15-person team? Because there's certain like technical requirements that you need a person for. Right?
Well, so like for like the Red Door team, or Buckle Up, the rehab thing. We're designing an app for them. There's the three of us, and then me and Jacob are mainly doing the hardware. I'm also doing the app design with Garrett. Garrett's a software designer, but Garrett's in school, so like, okay, we're gonna need to hire another guy, and we'll probably end up doing that. Like, that'll be fine. And then that guy might be a contractor, but I'm thinking about hiring a good friend. So it's like, and then if they actually show interest and want to help us actually build this, then they could come on as a partner, no problem. For Brainsatlay, we're never going to like contract work necessarily. We're thinking about doing like a bounty system, which is more or less that, because there are people willing to just give us money to put it up to help just let any student or researcher just make us the algorithm, and then they can have $1,000 or whatever. You know? Why not? It's a weekend for them. And I don't know. There's a lot of these things where we can sort of delegate, I think. We don't need to be so aggressive about the money now because it's so cheap for us to actually prototype all this stuff. And then it's cheap for us to actually scale it. Like for us, I mean, I'm fine living like a pauper basically because I would be in like a grad school program otherwise with no money, or I'd be in debt more likely. Like it's fine for me right now to be modest. And then I feel like once we have this to a point where it's so legitimized, like we'll probably have more money than we know what to do with from scaling, hopefully. And then like we can just ride the community and put that all back into the community and not be like.
I have a question about the model, Josh.
Yeah.
So do you actually when you develop this open source GPL framework platform web app and the devices that you sell through this framework, do you also develop IP and protect the device, or do you protect the distribution?
I immediately slap like an MIT license on all the hardware because that protects me in a basic way. That's it. The only reason I won't publish something right away is because I don't know if it works and I don't want to like waste your time downloading it. And like unless I make it really clear it doesn't work, which some of my old projects on there you'll see like, it does not work.
So the only protection is for the user, a warranty that it works, but then they can use it and resell it.
If they're buying an actual product from me, I give them warranty, right? And there's basic things like, I'm not trying to diagnose you or treat you. Like, I have to give the basic FDA.
Yeah, right.
Of course, I don't sit there and try to make claims necessarily about like, oh, you can optimize your mind. No, I don't care. Like, I'm just like, here's some interesting physiology. Here's breathing exercise you do. Watch what happens. Good. Go talk to a doctor about the rest if they have any idea what this is at all.
And what about somebody tomorrow finds out that this platform is extremely interesting? They copy it and then they protect it under their own IP and license, and then it's not usable anymore.
It's not gonna, like, all our stuff that we're writing, like we're banking on, is all published and licensed. Okay, so I mean, if they wanted to, you could take Brainsatlay as a library, and that could just be something to, like, say, run the data aggregation through. But you still have all the SALT framework over here that you're doing. That could still be yours. And the thing is, you could take that and say, well, Brainsatlay is open source. You'll see this in video games. You'll see the whole list of open source libraries that they use.
Yeah.
But then they're like, but this is proprietary. You can still do that. But in terms of if you're going to then develop functionalities in Brainsatlay, those have to go to Brainsatlay, or at least, like, you're not going to necessarily be contributing to anything if you don't, like, want to help us. You can help yourself. That's really part of it. That's fine, right? Yeah. Like, all my designs are MIT. I've seen, I looked at the Mendy design, and, like, there's really nothing unique about it compared to, like, stuff.
What's the Mendy?
The Mendy's the commercial HEG that was released. They sold like $3.5 million worth of HEGs. But it's just a single infrared LED, and then they have 2 channels, and I think they have a short channel here for something. What was so funny is, like, the specs of those sensors, like the ones I recommended 2 years ago. it's like there's really not a lot. It's not like I don't think they copied me necessarily, but it's like there's not actually a lot out there.
Wow.
That you
2 million raised. It says Gareth says 2 million raised from Mendy.
2 million. Okay, yeah.
I guess that's good marketing.
Yeah, they did a good job. Apparently, like, they haven't shut up to a lot of people yet. But I was on Crowdsupply at the same time. I was 7,000. I did a good job. What'd you say, John?
I don't want to be too much of a cynic.
Sure.
Let's say, like, in a devil's advocate, from a devil's advocate perspective, I do feel like I see sometimes a lot of you can almost tell when, like, more than 50% of the more than even like 70% of the investment in a startup has gone to the branding, to the marketing, to the non-core stuff. And it's just really, and then you see like a three-channel EEG from the 1970s core technology, doing something that's probably not validated. And it just makes you sad, to see,
you want to know
really jazzy, and then you get into the details, and it's like nothing. There's nothing there.
I heard this from the horse's mouth. No, the reason they do that is because they're doing market discovery. They're not actually marketing a product yet. They're doing market discovery. They have a concept that a branding agency or a guy with a business degree made from his entrepreneur class or something in college, and they work it out really nice, and then they're like, okay, if I can raise this many sales, then obviously that justifies a VC funding, blah blah blah. Like, that's clearly a vertical that I can climb. That's why they do that. So I think the Mendy might have been that. I think they probably had some prototypes, but they probably didn't have a commercial model yet until they were way too deep in funding.
So it comes to the one of the last questions, I guess. We have about 10 minutes left on the schedule tonight, and that's been a great discussion. But when we consider this open source, open hardware, paradigms, we can call it like this, then you would detach yourself from the dynamics of venture capital, and then you want to raise money by crowdfunding, which is a different model, which is also well established.
Yeah, for the small scale, just to get ourselves out the door with something.
Yeah, and that's great, like you say, to bootstrap your endeavor. But then, like John was saying, when you want to scale up and then you bring it to the next level, right? So you don't have an infrastructure, you don't have a business model to bring it to the higher scale. So because you cannot count on infinite expansion, right?
We do. I mean, like we make sure our margins are set in such a way that we're able to not just make our money back, but we're able to reinvest, right? And also have some money to live. So we make sure we're taken care of there. Like, you set those margins. It's just, dude, when you have an efficient business structure and the people who are all doing the work are actually necessary, the costs to produce are nothing. Like,
yeah, but one thing is production.
The margins you need to charge are actually way less. What people are really charging right now, probably 10 to 100 times what they should be doing.
Understood. I don't contest that. I contest the fact that to make outreach, you will have to do marketing yourself.
That's fine though. And again, it's all happening through word of mouth, man. I've gotten hundreds.
Oh, I think Josh was falling.
Pause for a minute. Yeah, he'll come back. I think he's saying he's very popular.
I think I hear word of mouth. But if you need to scale, it's really tough, right? You know, the same criticism about marketing applies to everybody. So when you need to scale your business, it's really tough. Maybe the strategy is not well in place at the beginning, but then when it comes to that, scaling is really tough. And you know, we deal with the rules of the market, and then the market always wins. So it's not any VC or any student of a business class that, you know, invented the market. So at some point, even this kind of crowdcasting crowdfunding model, they will need to scale to reach out, you know, the entire population, and that's going to be the critical mass.
Right? I know it's not the same domain, but you know, like Wikipedia, right? That's not a market entity.
Right.
Some version of thinking about Linux is similar. I'm sure that so there are exceptions, but obviously there's a small number.
Understood. And then it might be tough, right? It might be really tough.
Yeah, but I think this thing about ecosystems, right, and communities, right? I honestly think this is a very substantial point, because I don't see this from the perspective of like investors and kind of new people who are horizon scanning for where to go next in kind of developing some commercial domain, but the engine of progress in most science, certainly the kind of science that I see is like effective communities of enthusiastic people who understand the value of sharing their stuff and kind of just share a kind of enthusiasm for working in that way. And I honestly think like that is an engine of innovation, and if you can channel that and if you can tap into that, then great things will happen. And it's not the case that has been like, in terms of the technology and the software and the hardware in like most, you know, private commercial companies, like they're not tapping into that engine of innovation in the same way. They're like somewhat kind of contained boxes that are figured out a thing and then kind of making it work really well, but they're not kind of getting this like large number of very smart, passionate people to kind of push, as Josh was saying, like push a mountain, right?
For sure. And Josh,
time for that. Josh,
it's good to have you back, and
again
using Garrett pseudonym. But basically, the criticism that I was raising was that you know, crowdfunding is difficult to scale.
Yeah. Oh, I think I was cut off in the middle of responding to that. Well, it's pretty much like, as long as you do the work, right, and you make a good product, and you're actually
we're struggling to get an answer from from Josh tonight. I think, it's kind of destiny that this answer gets into.
And I can look back at my numbers and I can see that trend happening. It's really based off of my resources, because I literally started with 0. 3 years ago, I was literally picking mushrooms and using my last $20 to go buy my Arduino so I could learn how to program and stuff. Who cares? Like, I did it because I knew it's like, this is what I need to do if I'm going to get into this in a serious way. And you just do it, and then it keeps going. If you're doing a good job, and in my opinion, if you're actually ethical and sort of like, like in line with like nature in a way, like it's going to work out. I don't know. I see like if we're gonna like solve a lot of these really serious like social dilemmas, like we have to find a way to actually harness all this technology in a way where it's actually really democratic and mutual. There's no of these stupid incentives getting in the way of actually us doing the things that need to be done. I mean, look, I was definitely radicalized a little bit at NASA with these guys telling me about how they're like, yeah, we were ready to get on a goddamn rocket to go to Mars, and then they pulled the plug. So they're like, that's not marketable to our politicianing. Like, not like this is amazing and like, it's actually a drop in the goddamn bucket for science, like in real terms. And then again, just we'll wait till some private company can do it.
I understand your frustration, John. Well, thanks for this is a great perspective, and I think it's eye-opening for many of us, for sure for me. And I learned a lot tonight, both from for both of us, I think. John, what do you think?
I said it before, I'll say it again. I always learn a bunch of stuff when I talk to Josh Brewster, and today was no exception. So great
we love to have you.
Anytime,
we love to have you and Garrett, and then all your all your other friends and collaborators. Hi guys, good job.
Low budget.
He says good job.
Yeah, Josh, it was amazing to have you tonight. And we want already to thank you for what you said and for your presentation and for the many questions that you were able to answer and for the debate that we had tonight, which was very interesting, and to raise these important topics about data sharing, about crowdfunding, and then about open hardware and open software, and then showing your amazing framework and web app. And talking about,
I didn't even get to the demo. We just talked. That's okay.
Do you have it ready? You want to run it?
Let me. Okay.
5 minutes.
I can pull it up on this computer. Can I?
And meanwhile, you prepare, Josh. I will announce the.
I need an adapter. Yeah, it's.
Oh, this Mac doesn't have USB.
I'm gonna mute you. I'll mute you when you're ready. Okay.
Sure.
Meanwhile, Josh gets the demo ready for the audience tonight, I wanted to announce the next episode of this season 1, which is going to be an amazing speaker. Actually, we will have 3 speakers next time. We'll have Maciej Rodzinski from Brainsatlay, which is a company in Poland, and they will speak about gaming and brain-computer interface. And he has a very good, very time-sensitive brain-computer interface that he will demo for us. And then we will have 2 exceptional guests, Anna Aponenko and Sanjay Kayanathan from Accessium. And then we show us Sanjay is quadriplegic, and in our attitude to diversity, we want to include also projects from Sanjay that shows how to control a car with his face. So he invented a technology to have secondary commands in his car that he is commanding with 2 hands. Movements with face control as well for secondary command. So this is going to be episode 3, and we will have Sanjay, Anna, and Maciej online next Wednesday at 8:30 p.m. And now, Josh, you're ready with the demo, I guess? You have to unmute yourself. Wait, I'll kick you out and pick you up again. Here we go. We will have Josh in a few seconds.
Okay, there we go. No, it's called this max button on the thing that was not working. Okay, let me share my screen here. If I can click the button. Okay, there we go. Okay, here we go.
All right.
So this is going to be very simple. This is our sensorium. Okay. What is up with this Mac? It's freaking me out, man. Okay, there we go.
So there's your web Bluetooth connection.
Josh is about to reconnect, I guess.
What is that? Okay, so let me just describe what's going on right now. I don't know how good the frame rate is, but so you can see my pulse there in that red and green line. The red line is the red light. The green line is the infrared light. Let me just stop moving around so it's really clear. But you can see my pulse wave in there. Anyway.
So this is the web app interface that Josh was speaking about. So it's app.brainsatlay.com. And he connects.
Gives you a relative change in blood oxygen ratio. It's a very simple biofeedback metric. You can call it the perfusion index, but it's not quite what they use in perfusion index. This is really it. So it's just tracking my blood flow and my blood oxygen content relatively. And then if I do breathing exercises, or if I just breathe, there's changes in the blood oxygen ratio that happen, and you can see changes in your pulse as well. And what you try to do is you just try to do breathing exercises, and you try to interact so that your score or this ratio goes up as much as possible, basically. And then the idea there is that you're increasing your brain blood perfusion as much as possible. And there's actually spec studies on people who've done this. Like this is from the Biofeedback Institute, where they actually had people do this like a few times a week for several months, and then they took before and after images of their average perfusion, and it was like for like recovering addicts and stuff. At least the images they showed of a few brains, it was like more than it was like before. It was definitely obviously like below average in terms of the amount of perfusion you saw. And then afterwards, it was like above average. And so these are people recovering from like addictions or whatever other chronic stress-related disorders. And it's kind of amazing. Some people can sort of just like shut down panic attacks and stuff doing these exercises.
Wow.
Very interesting. There's a lot more to it. So yeah, okay. So then, here I got my data. It actually saved the data. Oh my gosh.
Josh, what's the oscillation on the greens and the reds there? Is that a...
That's my heart rate. That's my pulse.
That is your heart rate. Okay.
Yeah, so let me go to, I can give you a better plot. I can give you a better plot. Well, I show the U plot first. Is it?
Temperature.
Oh yeah, this thing gives out temperature. Okay, why is this? It's glitched out. Okay, we're gonna just go to the session manager and show you the after data. This automatically will save your data, and then you can also automatically save it as well.
So these are all data sets?
Yeah, hold on, I can't see anything. This dictionary thing keeps coming up. Okay, now it happened. There we go. Huh, this plot was working a second ago. Well, like literally yesterday. Hold on.
It's a demo effect.
Yeah.
You're right.
Oh, this is I'm the best for this.
It looks amazing.
It's pretty snappy. It's pretty snappy when it works. It's still alpha, guys. This is all alpha. This is like a rough draft of viewing the data. Well, I guess it just doesn't. Your Mac just doesn't like this app. Well, that's okay.
Because this is actually, like you said, it's all like less than a year old.
Well, so we started working Brainsatlay in end of February, March. Yeah. Okay.
Right.
We can probably show the EEG data. Why did this?
Sometimes. Most of the time.
And then it opens a dictionary.
Well, that's just you poking around on
That's your Mac being a Mac. Okay. This is so bad. Let me jump back to my computer because then I can actually show this.
It's okay, Josh. You can leave the link for the audience. We were out of time tonight.
Okay.
But I think you can say two things about the format. Maybe the synthetic 0 is the data format that you have, your proprietary format.
It's not proprietary. You can download. It saves CSVs that you can just pull, and then you can even re-upload the CSVs. Okay, I guess I have no idea what I'm doing.
Can you leave a couple of comments on when you are back? I guess that's it for tonight. What do you think, John?
Yeah, I think this is a good place to wrap it up. I mean, we could
Oh,
get a very long demo, but I think
that's okay.
Oh, there's a lot to show. I think what for people who are watching, like, just go to the website and check out and click on some of the boxes, because a lot of the stuff doesn't actually require the EEG data. It's it's these interesting neurofeedback kind of scenarios. Some of them are
there's
3D VR type things.
You can run too. You can see how the data
they'll initiate a synthetic data stream, so they'll kind of show you fake data to see like what it would look like. So you definitely get like a good gist of all this stuff by just going to the website right now, like irrespective of you having any device or so on. I guess, Josh, what I would suggest is, if you guys, I don't know if you have it yet, but like have a little YouTube video or something, like a demo.
Yeah. Well, we want to turn it into.
We'll connect to Josh, I guess. I think I dropped the link of the web app here in the text. Josh, we were saying that we're wrapping it up.
Yeah.
I dropped the link in the text chat so that people can play around with your app.
Cool. Great. Thanks
so much, everybody. And it was, again, the second episode of the series. It was really fun for me. And I had the honor and then the pleasure to have you and Garrett online. So thanks again to everybody.
It's always fun.
See you next Wednesday.
I think, it might break though. I think it was some of the VR games glitched out with the shaders because we're noobs.
Good luck with that.
It's better with the Vive or something where you're using your desktop and then it's like projecting the browser. But you can click and use WebXR with 3JS, so that's really cool because we can make WebXR experiences in this. There's even a Unity build, by the way. Somebody made a Unity build that they actually loaded into Brainsatlay, which is it's on there. You can see it. It doesn't do much, but
Can you drop a link to the documentation maybe?
The documentation. It's so out of date, man. We have a lot of work to do. Well,
can you drop an email?
I'll give you an email. Within a couple months, we'll do like a more formal release once we're really confident. Like we know everything works. Like it's all proofed now. It's just a matter of wrapping it up into something that's like.
So we'll have you back, right? How about that Neurotech showcase, like season 2, season 3, however it lines up, and we'll do that. Have that full demo.
We'll soon speak about data and applications. So Josh, stay online. Maybe drop the email for whoever wants to reach out to have the slides for tonight. Drop it in a text box, and then we're good. Or we reach out to Julian separately. Is that fine with you?
Yeah.
Okay, guys. I had a great night.
Same.
Thank you guys so much.
To the next
Thanks,
episode.
Everyone, for checking in.
Take care.
Good night, everybody.
Good night.